you should see the solder in the center start to melt. And the software crashed. Amazing. Actually, I think this worked really, really well. Okay, well, oh, there's a short. Hello and welcome. Today we're going to build a soldering station. We're going to build the AxxSolder. It's an open source JBC style soldering station. In this video, we're going to try to put it together, make it work, and depending on how things go, we might be able to test it, or I'll test it on a separate dedicated video. So let me thank today's sponsor, PCBWay, and let's get started with the content of this box, which is quite scaring. AxxSolder is an open source project from Axel Johansson in Sweden. So thank you very much, Axel, for sharing this with the world. And as I said, it's a JBC style soldering station. Now, why did I decide to build a soldering station? I have a JBC soldering station, but over time, I realized I wanted another one, and everything I could try, everything I tested, everything I purchased personally, it didn't really work very well for me. Some time ago, I purchased an iShun T3A. It was well regarded online and on forums, and it was called the JBC Killer, so I purchased it with my own money, and shortly afterwards, I realized, well, it had quite a lot of voltage leak and current leakage from the tip. And I think it was one of my viewers at some point, they mentioned on the comments of my T3A review that there was this open source project, and I started chatting with Axel, and he told me that when properly built, well, the AxxStation doesn't show any voltage or current at the tip. Now, meanwhile, Bacon got in touch and they sent me a couple of soldering stations, and one which I really like is the BK999, which is sitting here on my workbench, and I've been using it for quite some time since I reviewed it, and it works totally fine. So this AxxSolder project, well, went a little bit in the back burner, let's put it that way. There are so many components inside this box, I got a bit scared, let's put it that way. And because I now have two working soldering stations with no voltage and no current, I've always procrastinated and never really got to put this together. But I think today is the day where I have no excuses. I really would like to put this together, even just to justify the amount of money I spent in components to put together one working AxxSolder. So let's open this box and see what's inside. This is the reason why I've been procrastinating in trying to put together this station. There are quite a lot of components, power supplies, ICs. As you can see from the PCB here, there are quite a lot of very small components. I would say mostly on this side, but also on the other side. The other side is much simpler. And because I had a perfectly working Bacon station on my shelf here, well, I thought, I don't feel like building this thing. It feels very complicated. I'm sure it's going to be, but it's also going to be fun. So yeah, hopefully we're going to have fun today. Now, the AxxSolder is based on a very specific power supply. I mean, this is a Meanwell. It's what Axel recommends. I guess you can buy something else. My understanding is that this power supply has the negative of the power supply, which is not referenced to ground. And this is critical, in my understanding, to make sure that you can actually properly ground the tip of the soldering iron, even when it's been energized. So that should be critical in delivering a tip which doesn't show voltage or current. The website says that if I'm using a USB power supply, well, then I'm not going to have that insulation, the grounding that I can achieve with one of these power supplies. There is also another Meanwell boxed, how can I call it, like with a plastic shell power supply, which is similar topology, so with the negative of the output, which is not connected to ground. On the website, there's all the instructions on how to select the proper power supply for your AxxSolder. Now, when it comes to the PCB and the 3D printing here, I think I went for the portable soldering station, which I can then glue or attach or screw onto something else. I think there are a number of different versions depending on what cradle you're using, what you would like to do with your soldering station. As you can imagine, everything was provided by PCBWay. And I have to apologize with PCBWay because this box, including the 3D print and the PCBs, have been sitting here for more than a year. So I'm really sorry. They were very understanding, but yeah, that's not something I feel proud of. With the PCB, I order from PCBWay the stencils as well, which I never use myself. These are the stencils. They're basically sheets of metal which should make applying the the solder paste much more convenient. This is probably if you need to build more than one. I was just curious because I never tried them myself, so thank you very much, PCBWay. Once again, ordering the stuff from PCBWay is extremely simple because on the website you can find the Gerber file. Under AxxSolder hardware, you have a fabrication folder. And that's a very convenient zip file with all the files that PCBWay needs to fabricate your PCBs. Download it, upload it to PCBWay.com, and that's it. I did change the color of the boards because somehow I like red boards, and I ended up with the, I think it's called the ENIC gold-plated treatment. And the 3D print, of course, comes from PCBWay as well. It's a similar process. You just need a different file. It's on the GitHub. The quality, as you can see, it's absolutely fantastic. So I'm really looking forward to put this together. I believe it's not going to be a trivial task. I mean, there's going to be quite a lot of stuff to attach, to solder, to check and everything. So I'm looking forward to the end of this video when hopefully the soldering station will come to life. Take a look at PCBWay.com, the affiliated link is down below in the description, and let me thank PCBWay for sponsoring my videos on my channels because their help makes these videos possible. So thank you very much PCBWay for your help and your patience on this long delayed project. Now let's start placing components on the PCB. To install all the little SMD components, I'm going to use this Mechanic iX5 Ultra. I did review this one. I believe this is probably a fake preheater, if you want to call it that way, because what is shown on the display doesn't really correspond with what happens on the top. But once you know that, spoiler away, I mean, it can be okay. And most importantly, the platform here is kind of big enough for this. Yeah, more or less it fits the PCB, so that is great. Now, there are quite a few small components to install on this board, and obviously you can't really read anything on SMD components. So Axel made an interactive bill of material, which is a web page like this. On the right, it's configurable, but on the right hand side, I have the drawing, the map, let's call it that way, of the board itself. And on the left hand side, I have all the components. Like these are all the 100 nanofarad capacitors, and you can see where they're going. And if I tap this, the second line, which is 10 microfarad capacitor, you see where the 10 microfarad capacitors are going. And most importantly, if I don't know what this R10 is, I can just tap on it, and it will tell me it's a 220 kilo ohm resistor. The bottom line is that you have an interactive bill of material, which is amazing because you can see what is what goes where, and you don't have to struggle with the schematics or anything else. Now, I think it would be time for me to start finally populating this board. The first thing that I need to do is to apply the solder paste, which I've never done with the stencil. So I have very little expectations on the outcome, but let's see what I can do. Now, I received two stencils, one for the front, one for the back. I don't think I'm going to use the one for I think it's actually the front, but for this side, it's literally just a few big components, so I can do them manually. So the plan here is to perfectly align the stencil, and it's really, really critical that the alignment is perfect. Something like this. So I think I'll try and apply some tape at the back and see if I can get this as aligned as possible. And I think I've got it as best as I can. Now let's try and apply the solder paste. Now I have this old tab of Mechanic solder paste, and I understand that solder paste has an expiry date. Also that it should store it in a fridge. And I refuse to store lead in a fridge. So this has been living here on a shelf. Let's see if it comes with an expiry date. Well, it says manufacture 2022. I don't know what's the expiry. Oh, shelf life 1 year. So in theory, this has expired. I don't care. I can't just buy another one just for this. So we'll see how it works. Now, chances are this is pretty thick, pretty dense. So I'm not sure whether I might want to warm it up a little bit. Otherwise, it might be difficult to apply, but maybe that's actually a good thing so it doesn't spread everywhere. So let me try as it is, and we'll see what happens. Ooh. Actually, I think this worked really, really well. I think that's it. I think this is working. I would say this is just perfect. And again, don't worry when you have those small legs and you see the paste going a bit of everywhere. It's totally fine. Then the, how's it called, the surface tension induced by the flux will make sure that there are no bridges. And if there are, obviously this will need a little bit of time under the microscope to make sure that there are no bridges or little balls everywhere. I'm not going to show you all the components being installed. I'll do a little montage and I'll see you on the other side when it's time to bring the board up to melting temperature. I'll show you the way I like to put this together. It does take a bit of patience and a good pair of tweezers, but honestly, it's not that bad. First thing, spend some time labeling all those little bags so they match the interactive bill of material. It's absolutely worth it. Otherwise, you'll be digging through the box over and over again. Also, keep in mind most SMD components don't have markings on them. So if you mix something up, it can be a pain to troubleshoot later. Good tweezers are essential here. Find tips, clean and in decent condition. And if your bench looks anything like mine, well, maybe take a few minutes to tidy up before you start. Now, start with the first line of the bill of material and pull out exactly what you need. If it says 10 resistors, peel back the tape and take 10, no more. That way you know you've placed them all. Once you've placed everything for that line, move the bag out of the way, ideally into a separate box, so you don't mix up with parts you haven't used yet. Then just keep going like that all the way through. Don't stress too much about perfect alignment. Flux and surface tension will do a lot of the work for you. You'll probably have a bit of rework at the end anyway. Put some music on, take your time, and hopefully you'll end up with something like this. I have to say, I'm pretty happy with how it turned out. I skipped the capacitor and the buzzer for now. They don't love high temperature, so I'll add those later. Next, fire up the preheater to around 200 degrees. You should see the solder in the center start to melt. The edge will be a bit cooler, so you'll need to help things along with some hot air. Low airflow around 300 degrees works well. And a bit of extra flux helps everything settle nicely too. Overall, the result was pretty good. I only spotted a couple of small bridges, one on the MCU and one on these IC here. After that, I went back and reflowed a few joints and touched up a couple more. Probably overkill, but better safe than sorry. It's funny, these always look so easy in other people's video, but when you're doing it yourself, well, it's a different story. Once everything's cooled down, give the board a clean with some isopropyl alcohol and be gentle. Those tiny resistors don't appreciate a heavy hand. Then finish it off with some compressed air to dry it. And that's the front side done. I'm really happy with how it came out. Now onto the back, which is much simpler. Just a few switches, the screen and some pin headers. Those pin headers actually support the LCD. I somehow missed that at first, despite the big warning on the PCB, and soldered them the wrong way around. I only realized later when I tried to fit the screen. Speaking of the screen, I ran into a bit of a problem. The one I bought didn't match the footprint. He had extra pins, he was longer, and it didn't fit the case properly. And then it clicked. I had decided the recommended Adafruit screen was too expensive and went with the cheaper alternative someone suggested. As you can see, well, that didn't quite work out. Even if I'd bodged it in, it would need a firmware tweak to swap the SPI clock around. So in the end, I just bought the correct screen, the one I should have gone in the first place. So much for saving money. The Adafruit display, of course, just works. And once I flipped those headers the right way around, everything dropped into place. And finally, we're getting close to the finish line. Alright, we got to the point where it's time to give power to this thing and see what happens. The first step would be to supply 3.3 volts directly to the microcontroller. Normally this board would work with something between 9 and 24 volts, and then you have a number of voltage regulators generating other voltages, including 3.3 volts for the microcontroller. But we're going to proceed in steps. So first things first, I fitted here a little header, which is more or less the diagnostic header and is directly connected to the microcontroller, I guess. And I'm going to supply 3.3 volts through here. Now, first thing first, let's check the obvious. Do I have a short on the 3.3 volts rail? And I don't. I'm reading kilo ohms, which is totally fine. And since I'm here, let's check that the main input is reading something reasonable. So I'm between VIN and ground. And I'm reading mega ohms going down. Yeah, that's totally fine, mega ohms, kilo ohms. And I believe that Earth is a different beast, but just to check, yeah, I got mega ohms as well. So nothing obviously wrong with the rails. Now let me make sure that I actually have 3.3 volts out of my power supply. I'm gonna set the current limiter to 100 milliamps. That should be enough to prevent horrible things from happening, because I only have one microcontroller. I didn't order two of them. So hopefully that's going to survive this process. And yes, I'm reading 3.3 volts. The polarity is correct. So my green is gonna be my ground. Let me turn it off and we're gonna plug it up, or plug it in, as someone says. So let's turn it on. 3, 2, 1, go. Yes, it's stable at 40 milliamps. And again, I'd imagine there's nothing on the screen. Yeah, of course, there's nothing on the screen. But yeah, it looks fine. And that's it. I guess we can move on and start the firmware update. And then we should see some sign of life. And by the way, the screen is turned on. So definitely some little signs of life. I'm going to follow the instruction for the USB update I found on the GitHub for the AxxSolder. To run USB update, I downloaded this STM32 Cube programmer, and it's running here on the computer. The next step would be to plug the board into the computer using a USB-A to USB-C cable. You can use USB-C to USB-C, but as long as they don't have power delivery connection inside. Apparently, power delivery can mess up the connection. So by using a USB-A to USB-C, you make sure that there's no power delivery involved. I will have to put the device into DFU mode, and that is done by holding the S3 button. It's also said boot on it, while I'm plugging USB. So I'm holding S3 and I'm plugging the USB cable. 3, 2, 1, go. Oh yes. I heard a USB notification on Windows, but I don't see anything here. I never used this software. I'm trying to teach myself how to use it. There is no target information here at the bottom, so I'm a bit concerned that maybe something is not working. I do have a light at the back of the display, so there's definitely power to the unit. Do I need to refresh something? Do I need to connect maybe? Oh yes, of course, I'm just jumping ahead. The instructions are telling me exactly. It says connect to the target by selecting USB and click on connect. Here. Oh, there we go. So I'm selecting USB, no DFU detect, and then click on connect. Okay, that's not great. We have an error message. Invalid USB port name. That looks to me more like a Windows problem than an AxxSolder problem. Oh, there we go. So I refreshed port, and now I have USB 1, because obviously it's detecting something on USB 1. So I'd imagine if I connect now... Yes, it's working! Look at that! It's connected to the chip. And it's completely empty, of course. That's totally expected. The next step is very simple. I just need to load the latest firmware, which I've downloaded from GitHub. So it's going to be, I guess, on the open file. Hello. And the software crashed. Amazing. I think it happened before. I thought I left it open, and then I found that it was not there anymore. I thought maybe I closed it. No, it crashed twice. I have a feeling it might not like my network drives. Let me get back to that point and I'll come back to you. No, it doesn't like my file system. I don't really know what to do. I don't really know what to do if it doesn't like my file system. Well, the internet is suggesting it's an issue with some Visual C++ files. So let me do what they say and hopefully it will work, because they are reporting exactly what I'm seeing here on my laptop. All right, I've done what the internet said. Is it going to work? Let's try. Open file. It's working. Fair enough. Okay, this is the file I've downloaded from the GitHub. There it is. All I need to do is to click on download. It's half covered here, but it's definitely here. That's it. It's writing. File download complete. And would you look at that? It's working. Look at that. Amazing. It's I don't build these boards very often, especially with so many components. It's such a reward that after all those components, all that soldering, all those things, and it's working. It feels great. If you follow this channel, probably you like these things, you understand what I mean. The switch is working here. Yeah, obviously there's no input voltage. The button are also working, 340, and I don't really know how to use this thing, so I'll have to teach myself. That's the setting, I'd imagine. That's pretty nice, pretty intuitive. I never used this before, and it was pretty intuitive how to use it. Amazing. As you can see, I'm on firmware 3.6.1. That's the one that's available at the moment. But this is great. Fantastic. Well, let's not celebrate too early. There's so many other things to do. I guess, I'll have to put everything together, attach the handle and everything and the power. But for now, this is a great success. I'm really happy. Let's move on with the next step. It's time to put everything together, wire everything together. I don't have fancy colored wires, so I've come up with this. These are 1 square millimeters, so they should be totally fine. They're quite flexible. I think there's either silicone or something like that. So they're going to be totally fine, but obviously I'm going to use the same color for multiple things, which is going to be fine as long as you know about it. I think I got all the screws, all the connectors, all the nuts, and but most importantly, before I go ahead, I forgot that I still need to install the capacitor and the buzzer. Let's do that now before I forget, and then I'll proceed and I'll start putting everything together. Alright, I've got VDD coming in, nothing else connected. I'd like to do a test run. Now, one thing I would recommend that you triple check is that you don't have any strands coming out of the wires and they're not shorting anywhere or anything. Okay, I'm ready to power up. 3, 2, 1, go. There's really nothing being used and nothing is happening. Now I'm wondering whether my my little botch connection here is actually working, because I didn't want to wait. So I just wired this up. Let me check with my multimeter. Maybe it's just not power going into the PCB. Yeah, no, there isn't. Okay, so panic over. I just need to make a better connection, obviously. Oh, the switch. Of course there is an on-off switch. I forgot about the switch. Look at that. Yes, of course. So it was probably totally fine. Yep, obviously with no switch it's not gonna work. Try this again. 3, 2, 1, go. Yes, yes, perfect. Look at that, it's working. And it's drawing 50 milliamps, 49. Perfect. Now we clearly have 3.3 volts because the microcontroller is working, but we should be able to measure it here. Yeah, 3.299, very precise. And 7.35 should be accessible here on this inductor. There we go, 7.30. Supposed to be 7.35, I guess is within spec. I'll check with Axel. And well, we have VDD. That's where all the voltage is coming from. So everything seems to be working totally fine. Let me continue with putting this together. Alright, that's been a journey, but I think we've reached a point where we can power up and actually turn on the soldering iron. So first thing first, let me check that the power supply is outputting 24 volts. I've never used this power supply, so I think it's a good idea. Yeah, we got 24 volts, totally fine. Let's make sure the polarity here is correct. And it's totally fine, perfect. So let me plug my handle without the tip for the time being. I just want to make sure that the station is properly recognizing that this is a 245, and then I'm going to use it's a damaged JBC tip, so you know anything happens, it's not the end of the world. First full power up, 3, 2, 1, go. Yes, the switch has fooled me again. Hello. Something is not working. Ooh, why? Okay, well, there's a short. I see the LED of the power supply going off, or turning off when I turn this on. Yeah, there is a short somewhere. Okay, probably I caused a short while I was reassembling it. So let's have a quick look. That's not a good start, is it? I would say we do have a short. Yeah, it's reading something like 2 ohms, so yeah, that's definitely not normal. And I'm hoping it's just a stranded wire touching something that shouldn't be touching. I removed the VDD wire and I believe the short is gone. Yeah, it's now reading mega ohms. This is totally fine. I'd imagine that was my short. I just couldn't see it. So let me fit it back in, and this time I'll check for shorts before powering up. Okay, everything is back in. There is no short. So let me close it back and then I'll check for short when it's closed. And then we'll try again. Clearly there is a short somewhere once I close the enclosure. Let me look into that a bit more. Where is it? All right, well, I found the short. It's... I was basically pushing the wire into the header here, where the 3.3 volts and ground and stuff is. So I'm hoping... yes, there is a ground pin in there. So I was shorting 24 volts to ground through that terminal. Yeah, it was just going on top here. There you go. Perfect. Problem solved. Let me fix that. And the short is gone. Well, I would say that was a close call. If I had shorted 24 volts into something else, I'm not sure the board would have liked it. Well, hopefully that actually didn't happen. I don't know yet. Let me turn this on again and see what happens. 3, 2, 1, go. This is working, though the power supply is making a whining noise. Maybe that is totally normal. I'll check the current being drawn from the power supply. That was what my bench power supply was drawing. So this is totally fine. And yes, handle type to T245. So this seems to be working totally fine. I'm following Axel's instruction and set just something very low in temperature, though this JBC tip is damaged, so I don't really care. I'm gonna plug it in, and obviously I will do that quickly without burning my hand, and we should see something happening for the very first time. 3, 2, 1, go. But it's sleeping. Do I need to do something? Yes. Yes. Yeah, it's definitely working. This is so cool. Now this thing is making quite a lot of noise. The power supply is making a little whining noise, which is kind of cool. It sounds very science fiction, if you know what I mean. Yes. This is so cool. I'm particularly impressed. I'm reading 353. I don't think my JBC station would be so good. So this is absolutely impressive. I'm impressed by this thing, and most importantly, I built it myself. I never built anything so complex in my life. I think the most complex item that I built was the Blue SCSI, which I built on my second channel. This is so cool. This is absolutely super cool. And it worked first thing. Besides that short, there was no other issues, no other things that I had to redo, especially when it comes to SMD soldering. I am really impressed. The AxxSolder feels very, very professional. There is a very nice menu in here with lots of features. It's really, really, really fast to navigate, plenty of options, and it's very intuitive. Obviously, there is a calibration. There is, I can see power limits for different handles. You can change things for the display. It's quite nice. Most importantly, it really feels very professional. It doesn't feel like a project you found online and you build yourself. You buy some stations nowadays which are not so polished as this one. I'm really impressed. Now, I think this video has been long enough. So as I said at the beginning, I think I'm going to test this solder on another video. Also, I like to test them myself, use them for my own things for a little while so I can catch things which I wouldn't be able to catch in like half an hour playing with things. But before I close this video, there is one thing that I really would like to test, and it's the proper grounding of the system. The very reason I started this project was because I was looking for a properly working JBC style station with proper grounding. So let's do a quick check. I'm curious myself. So first thing first, do I read the voltage at the tip? Well, it's not zero. I'm reading a little something. What about in DC? In DC, there is absolutely nothing. I mean, if there is something, it's pulsing. So that might be the case. I'm kind of reading something. Obviously, the station is kind of idle. Let me try and go to, it's an old tip. I'll go to 430 degrees and then immediately read the voltage. No, it's still the same, 100 or something. Most importantly, do I read the current between ground and the tip? I don't read anything here in AC. And I don't read anything here in DC. That is cool. Let me run, I would say, my final test. The speaker test. One end of the speaker is connected to ground. The other end is going to touch the tip. So if there is any current, the speaker will make some sound. Let's try it. And I'm happy to report I can't hear anything. I might be able to hear a little something if I stick my ear to the speaker, but I think that's splitting the hair in half. And I think it's completely fine. This is so much better. I would say this is the very first switch-in mode power supply soldering station, JBC style soldering station, which passes my speaker test. So this is absolutely impressive. I'm super happy. And I took out my Chi widths, which can go down to 0.001 milliamps, and I measured the current once again. And I was reading something like 300s, and so I didn't think too much about it, and I immediately got in touch with AxxSolder, say, hey, I'm reading 300 milliamps on the tip. Is it something expected? I thought you said I wouldn't read it, and it took me a little while that this is not 300 milliamps, it's 0.3 milliamps, which is, I'm sorry, Axel, I didn't mean that. I didn't think too much about it. I am incredibly impressed. This device works totally fine, again, without having tested it for a long time, and it was fun to build, so what could I ask more? Now, one weird thing that happened, at some point the display was showing some sort of corruption on top left, but then I went into the setting menus, came back, and it was fine, and it's still fine. So Axel said to keep an eye on it. He's never seen that before. I don't know, it looks fine, but obviously if it happens again, we'll look into that. Now let's get to some conclusions. I haven't really fully tested the AxxSolder, and I don't feel like in a position where I can tell you my final opinion about the station. It will take a little bit of time, so that would be for another video. I can only say that I'm really impressed. It seems to be working totally fine, and I don't see why I'm not going to recommend it. Now, the AxxSolder can be purchased from 5dimensions.sc. This is Axel's personal website. The most complete option is the portable station, the complete kit. You're getting what you're seeing here in the picture without the USB power supply, without the handle, without the tip. So there's still something else that you need to buy, but that's going to be completely assembled, PCB, all tested, done, more or less plug and play, especially if you're using USB. All the other options, they all include a finished PCB. So if you want to build it yourself, well, you will have to go ahead, order the PCBs and buy the components by yourself. Which is not a trivial task. I did that myself and it took me absolutely forever. There is a bill of material, I think it's for Mauser, maybe there is one for DigiKey as well. But number one, there is always something missing, so you'll have to spend some time trying to find an alternative. And also there are some of the components which will have to be purchased from somewhere else. For example, the high-rose connector, that's something that you probably have to buy from AliExpress or something like that. But most importantly, it's going to be expensive, because if you buy 1,000 S&D resistors from Mauser, well, they're going to be kind of inexpensive. But if you only buy 2 resistors, well, Mauser are going to charge you an arm and a leg. Now, unfortunately, AxxSolder doesn't sell a fully do-it-yourself kit, where you buy the PCB, the components, and you just put it together by yourself without having the hassle of going to different shops and buy different components. So if you would like to purchase the full do-it-yourself kit where you receive the PCB, the components, all the bits and bobs, and it's your responsibility to put it together, leave a comment down below. AxxSolder will keep an eye on this conversation, and if there is enough interest, you might think of making one of those kits available. Whatever you decide to do, I would definitely recommend that you buy from AxxSolder the hardware kit with the hard-to-find parts. Those little screws, for example, they're M2.5. They're not readily available and they can be expensive if you want to buy them in small quantities. And the final consideration about price. The portable kit, which once again doesn't include the power supply, doesn't include the handle, doesn't include the tips, is £176 on AxxSolder's website. So this is not the cheapest option available. There are cheaper and good alternatives available, but I'd like you to consider one thing. This is AxxSolder. There's no big corporation behind them. The website is AxxSolder Johansson website. So bear that in mind that when you buy a soldering station from Fine Dimensions, the money is going to a guy in Sweden. It doesn't go to a big corporation based wherever. So I hope you had fun building this AxxSolder with me. If you did, as usual, I'd appreciate a thumb up down below. And also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon. The links are down below in the description. There is a free tier on Patreon, so no excuses. But if you don't want to support me on Patreon, well, maybe you can buy me a coffee. And the link is also down below in the description. If you don't want to buy me a coffee, that is totally fine. And I hope you enjoyed the video. That's it for today. Thank you for watching. I wish you a great day and hope to see you again soon here on my channels for my next videos. Thank you very much and goodbye. Bye-bye.